Hi, pre-calculus students. In this video, we are going to cover example 2 from section 5.1 on quadratic functions. Here you can see in example 2, it wants us to find out everything about the parabola and then graph it without technology. Specifically, it says determine if the graph opens up or down, find the vertex, find the equation of the line of symmetry, x and y intercepts if they exist, and based on your information, graph the function without technology, and then find the domain and range. This is going to be a very important thing as we move forward because we want you to be able to graph a quadratic function without technology. So let's start with the first question, which says, does it open up or down? And we determine that by looking at a. Our number here, a, is -2. And since a is less than 0, we can say it opens down. So we have that one answer done. Now let's look at finding the vertex. To find the vertex, we could use completing the square, in which case we'd isolate our first two terms and divide the -2 coefficient out of both of them. But here we have a 5. That's going to make our calculations unpleasant. So let's use our other method. If we want to find the vertex of our function, where h is the x-coordinate and k is the y-coordinate in numbers, what we do is we say that h is going to be a -b over 2a. Very simple. So here my b is 5, so we have a -5 over 2. My a is -2. We already established that. So we have a -5 over -4. 2 negatives makes a positive, so we have a +5/4. That's my x-coordinate of the vertex. Then we plug that in for x to find our y-coordinate. So we'll have f of 5/4 will equal a -2 times 5/4 squared plus 5 times 5/4 minus 8. Cleaning this up, 5/4 squared is going to give us 25 over 16. Multiplying that by a -2, we'd have a -50 over 16. This is going to give us 25 over 4 and minus 8. So let's see, common denominator here. We could make all of these denominators 8 because 50 over 16 reduces. In that case, we'd have a -25 over 8 plus, if we multiplied these both by 2, we'd have 50 over 8 minus 64 over 8. Combining our numerators then, we're going to get a -39 over 8. So now we have found our vertex. Our vertex had the x-coordinate of 5/4 and the y-coordinate of a -39 over 8. All right, that is the vertex. Now we want to find the equation of the line of symmetry. Line of symmetry will help us graph this guy. So the line of symmetry is the vertical line that goes through the x-coordinate of your vertex. So the equation of the line of symmetry, SY, is x equals the x-coordinate, 5/4. Now that is the equation of a line. You have to have both the x and the 5/4. Don't say it's just a number. We have to have the whole equation of the line. Now let's look at finding our x and y intercepts. To find our x-intercept, we let the y value be 0, because when you're graphing a function, your x-intercepts come when y is 0. Your points on the x-axis come when y equals 0. So if we substitute 0 in for f of x, we have 0 equals a -2x squared plus 5x minus 8. Now we can factor this, but this cannot be factored. I already tried. So if you're having problems and you can't factor something, we can always use the quadratic formula, which is, of course, a -b plus or minus the square root of b squared minus 4ac all over 2a. That's a c there. So what we wind up with is let's see. So here's our B, and here's our C, and here's our A. So a negative B would be a -5 plus or minus the square root of 5 squared minus 4 times A, which is a -2, times C, which is a -8, all over 2 times A, which is a -2. So here, we're going to get a -5 plus or minus. Now inside here, when you take 4 times 2, you get 8 times 8 is 64, but we'll be subtracting that 64 from the 25. So that means we wind up with a negative inside the square root. If you wind up with a negative inside the square root, what you know is that you have no x-intercepts. So because of that, it's no x-intercepts, and sometimes that happens. All right, let's then get on to our y-intercepts. To find the y-intercept, that's going to occur when x equals 0. So if you substitute 0 in for x, you'll have a -2 times 0 squared plus 5 times 0 minus 8. Since these two terms become 0, our C value is always our y-intercept. So our y-intercept here is going to be 0, -8. All right, we're doing great now. If they exist, graph the function without technology and find the domain and range. All right, I'm going to throw some lines in here and we're going to try and graph this guy. Let's put all these pieces together. So let's start with our vertex, which is 5/4, which is the same as 1.25. Come on. 1.25. And if you change 39 over 8 into a decimal, you get a -4.875. Makes it easier to graph. So 1.25 is about here. -4.875 is right around here. So that is our vertex. Oops, might be a little further. Anyway, our line of symmetry is going to be the vertical line that goes through that. And that's at x equals 5/4 here. Then our y-intercept is 0, -8, 5, 6, 7, -8. And so we can go mirror image on the other side of this line in symmetry and draw a point. Our parabola does open down. We established that the first thing here. So then we go ahead and graph those points. All right, let's move on to our next one. Whoops, before we move on, I realized I forgot to answer the last two questions, what are the domain and range? So for domain, we look, are there any restrictions on values that we can place in for x? No, there are not. Plus, this parabola is going to continue to go further to the left and further to the right if you look at the graph. So our domain, of course, is -infinity to infinity. Now we're going to pull the range, which is the y values, off of our graph. As you can see, there's no graph above this y value, which we established to be a -4.875. So our range is all the values below that. So a -infinity to a -4.875, which you could also write as -39/8. And that it can equal that value. So we have a bracket on that side. All right, let's look at our next function. On part B, we want to find all of those things for f of x equals a -x² minus 7x plus 3. As you recall, the first thing it asks is, does it open upward or downward? So we look at our a. In this case, our a is a -1. Since that's less than 0 or negative, we can say it opens downward. What was the next thing it wanted us to find? The next item it wants us to find is our vertex. I'm going to ask you guys to do that. Pause the video. In this case, again, we've got an odd term in the middle, so it will be easiest to find the x and y coordinates of our vertex if we use this formula, negative b over 2a for the x coordinate, and then for your y coordinate, you plug that in, and we write that with this notation. Give it a go, pause the video, let's see what you get, and we'll go through it together. So in our vertex calculation, you would put the negative b over 2a would be the opposite of a negative 7 over 2 times negative 1, giving you a negative 7 halves. Then, so that's your x coordinate, and then you substitute that into your function to get your y coordinate. So we substituted in the negative 7 halves for x. Multiplying this out gives us a negative 49 over 4 plus 49 over 2 plus 3. Combining those sign numbers, we get 61 over 4. So that leaves us with our vertex of a negative 7 halves and 61 over 4, or if you prefer decimals, a negative 3.5 and 15.25. The next thing we want to find is our x and y intercept. Oh, nope, line of symmetry. So let's write our line of symmetry here. The line of symmetry is the vertical line if you have a function parabola that goes through your x coordinate of your vertex. So it goes through the negative 3.5. So the equation of that line of symmetry is x equals a negative 3.5 or a negative 7 halves. All right, now we want to look at our x and y intercepts. Our x-intercepts, of course, are found by letting y equal 0, or f of x equals 0. So the left side of our function here becomes 0, and we have 0 equals a negative x squared minus 7x plus 3. Even if we factored a negative out, there are no two numbers that will multiply together to give us 3 and add to give us 7. So we're going to need to use the quadratic function to solve this. So x is going to equal a negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's have you find the x coordinates using the quadratic formula. Pause the video and give it a try. Using the quadratic formula, inside your square root, you should get the number 61 because you have 49, and this will wind up being plus 12 because it's minus a negative 12, really. So 49 plus 12 is 61. Out here we have a positive 7, and we're dividing by a negative 2. So the two solutions it implies is the 7 plus the square root of 61 over negative 2, and the 7 minus the square root of 61 over negative 2. Giving us a negative 7.405 and 0.405. All right, so let's write those as ordered pairs. If we write those as our x-intercepts, we're going to say it's a negative 7.405 and y is 0. Also, the other point is 0.405, 0. All right, we're getting there. Now we just have the easy stuff left. Our y-intercept is what we get when we let x equal 0. And looking at our function, if we let this term have a 0 in it and this term have a 0 in it, then all we're left with is the 3. So my y-intercept is the point 0, 3. All right, let's give this a graph. I'm going to put some axes on here, and then we'll take it from there. Let's add everything we know to our graph. So we know it opens downward. I think I'm missing something up here. Right, the vertex is the point, a negative 3.5 and 15.25. So let's get our vertex on here first. A negative 3.5, here's 3.5 is in the middle, and then 15.25 is going to be in that range somewhere. Now, we know we cross our y-axis. Our y-intercept is 0, 3. So that's going to be right about here. Our x-intercepts we found here. Do those the same color. And negative 7.405 is right about there. And a 0.405, which is right about here. And we have our line of symmetry as x equals a negative 3.5. So that's this is not really part of our graph. It just helps us graph it. So that's the line x equals a negative 3.5. Now let's graph our parabola. Maybe we'll do it in blue. Goes like this. It crosses here, here, and there. So we have a pretty good idea what our parabola looks like. Our final calculations here are for domain and range. And as long as we're looking at a graph that doesn't have a practical application, like this one, our domain is going to be negative infinity to infinity. Now, if I talked about this being a ball that was thrown and I wanted to know when it hit the ground, then there will be a limited time. The domain would just be when the ball is in the air. But for these, where we're given a function to graph, the domain will be negative infinity to infinity. The last thing we want to look at here is range. And we have a pretty easy job going here. My range, my y values are going to keep going further and further down. So that starts with negative infinity. And then the highest y value it reaches was the 15.25. So that looks like this. All right. In our next video, we will explore the last question on our notes. Thanks for watching.